Okay, let's take a look at these problems. Our first one is the square root of 225. Now we can do our tree breakdown. And our primes are 2, 3, 5, 7, 11, sometimes 13. Probably 95% of our problems revolve around these right here. So I start with 2 to see if this is divisible by 2, and it's not. It is divisible by 3 though. The reason I know that is because 2 plus 2 is 4, plus 5 is 9. If you add the individual digits, which gives us 9, if that's divisible by 3, then this entire number is divisible by 3. And let's see, it goes under 7, 75. 3 is prime, so I circle it. 25 is still divisible by 3, because 7 plus 5 is 12, and 12 is divisible by 3. 3 times 25. 3 is prime, so I circle it. Now 25 is not divisible by 3, because 2 plus 5 is 7. So I go to my next prime, which is 5. And that's 5 times 5. Both of those are prime, so I circle them. So my prime factorization is 3 times 3 times 5 times 5. Now we're looking for pairs or something. Here's a pair of 3s, here's a pair of 5s. So a pair of 3 is going to come out in front as a single 3, and a pair of 5 is going to come out in front as a single 5. And 3 times 5 gives us 15. The cube root of 343. Okay, so I come over here, do my prime factorization tree breakdown. It's not divisible by 2, because my last digit's not 0, 2, 4, 6, or 8. See if it's divisible by 3. 3 plus 4 is 7, plus 3 is 10. 10 is not divisible by 3, so this isn't. It's not divisible by 5, because last digit is not 0 or 5. 7. Let's see. 4, 28, 63. Okay, it is. 7 times 49. 7's prime, so I circle it. Now 49 is 7 times 7, and both those are prime, so we circle them. So this becomes a cube root of 7 times 7 times 7. Now our index is the number in this little slot right here. And this tells you how many you're looking for. Now the square root, we're looking for a pair of somethings. Here we're looking for a set of 3 of something. In this case we have 3 7s. So 3 7s is going to come out in front, and our answer is 7. Now let me clean this off. And then we'll look at number 3. It says use radical notation to write the expression, simplify if possible. So we've got 49 to the 1/2 power. Now to put this back in a radical form, this becomes this right here. Now how it works, when you have a fractional power, if you put it back in a radical form, whatever number's in your denominator, that goes in the slot right here. That's your index. Whatever number's up on top is your power, and that goes inside right here. Well, a 2 is the same as a square root, so I can drop that, and first power doesn't do anything. And 49 is 7 times 7 if I did my tree breakdown. With a square root, we're looking for a pair of somethings. Here's a pair of 7s, so a pair of 7s is going to come out in front as a single 7. And that's our answer. Number 4, we got x to the 7/8 times x to the 1/8. And it says use properties of exponents to simplify the expression, write with positive exponents. Well, these are both x to a power, and we're multiplying, which means we'll add our exponents. So that becomes x to the 7/8 plus 1/8. 7/8 plus 1/8 is 8/8, which reduces to 1, which simply gives us x. 18th root of x to the 3rd. Now this is telling us to use rational exponents to simplify it. Rational exponents means fractional power. So I want to put this in a fractional power form, rational exponents. So this becomes 3 over 18. Now this is going backwards of what we did in step 3 or problem 3. Whatever number's in your slot here, that's your index, goes down in your denominator. Whatever power is here goes up on top. Now 3/18 simplifies. Top and bottom both divisible by 3. So 3 divided by 3 is 1. 18 divided by 3 is 6. And that would be your answer. Number 6. Let me clean this off. We got square root of 32 times the square root of 98. It says use the product rule to multiply. Assume all variables represent positive real numbers. If I did tree breakdown each one of these, 32 is 2 times 16. 2's prime, so I circle it. I'm looking at my first prime. I didn't say it, but we're looking at 2. 16 is divisible by 2. 2 times 8. 2's prime, so I circle it. 8's divisible by 2. 2 times 4. 2's prime, so I circle it. And 4 is divisible by 2. 2 times 2. It looks like we have 5 2's. Now 98. Start with my first prime, which is 2. It's divisible by 2. 2 times, let's see, 2 times 49. 2's prime, so I circle it. This is not divisible by 2. I go to my next prime, which is 3. It's not divisible by 3. I go to my next prime, which is 5. Not divisible by 5. I go to the next prime, which is 7. It is divisible by 7. So it becomes 2 times 7 times 7. It's always a good idea to simplify radicals before you do anything else in a problem. And that's what we're doing. Square roots, we're looking for a pair of somethings. Here's a pair of 2's, so that's going to come out in front. Here's a pair of 2's, that's going to come out in front. So we're going to have 1 2 comes out, and another 2 comes out. And when they come out with multiplication in between them. And we're left with a single 2 inside. Now here we got a pair of 7's. This pair of 7's is going to come out as a single 7. And we're left with a 2 inside. Which gives us 4 square root of 2 times 7 square root of 2. Now if you're multiplying radicals together and you have numbers out in front, you multiply numbers separately. 4 times 7 is 28. When you're multiplying radicals together, assuming they have the same index, you multiply what's underneath them and put them underneath a single radical. So square root of 2 times square root of 2 is square root of 2 times 2. Now we're looking for a pair of somethings. Here's a pair of 2's, so that's going to come out in front. So that gives us 28 times 2, which gives us 56. And that's our answer. Number 7. Let me clean this off. We got, what do we got? Square root of 11 over 9. Well, we can't have a fraction inside of a radical. But we've got a property that says you can split it up. You can put a radical around the top, and you can put a radical around the bottom. Now, we can't have a radical in the denominator, but in this case, square root of 9 is 3. And so that gives us our answer. And that meets our two criteria. You can't have a fraction inside of a radical and can't have a radical in the denominator. Number 8. Add or subtract. So we got 6 square root of 6 minus 8 square root of 54. Always you want to simplify your radicals before you do anything else. 6 I can't do anything with. That's 2 times 3. 54 though looks like I can do something with. Do my tree breakdown. It's divisible by 2. 2 times 27. 2's prime, so I circle it. 27 is not divisible by 2, but I go to my next prime, which is 3, and it is divisible by 3. because 2 plus 7 is 9, and 9 is divisible by 3. So we got 3 times 9, 3 is prime, so I circle it, and 9 is 3 times 3. And both those are prime, so we circle them. So we're going to have 6 square root of 6 minus 8 square root of 2, and then we got 3 3's. Now this is a square root, which means we're looking for a pair of somethings. Here's a pair of 3's, so they're going to come out in front as a single 3. So we got 6 square root of 6 minus 8, and I bring a 3 out, single 3, and we're left with 2 times 3 inside, which is 6. So that gives us 6 square root of 6 minus 24 square root of 6. Now you cannot add or subtract radicals if the radicals aren't the same. And notice these are both square root of 6's now, so they're the same. And if they're the same, you add or subtract the numbers that's in front. 6 minus 24 is negative 18 square root of 6. And that's our answer. Let me clear off some area here before we do number 9. Two cube root of 2 minus 4 cube root of 128. Okay. Now 2 I can't simplify any radical wise, but 128 looks like I can. 128 is divisible by 2. 2 times 64. 2's prime, so I circle it. 64 is divisible by 2. 2 times 32. 2's prime, so I circle it. 32 is divisible by 2. 2 times 16. 2's prime, so I circle it. 8 is divisible by 2. 2 times 8. And 2's prime, so I circle it. And 8 is 2 times 4. 2's prime, so I circle it. And 4 is 2 times 2. And both those are prime, so I circle them. So we got 1, 2, 3, 4, 5, 6, 7 2's. Okay, so 7 2's. 5, 6, 7. Now our index is 3, which means we're looking for a set of 3 of something. Here's 3 2's. They're going to come out as a single 2. Let me actually write that out. When they come out, they're multiplied by whatever's already out there. Here's another set of 3 2's. Because our index is 3, we're looking for a set of 3 of something. And they're going to come out as a single 2. And then we're left with a single 2 inside. Okay, so we got 2 cube root of 2 minus 4 times 2 is 8 times another 2 is 16 cube root of 2. Now remember, we can't add or subtract radicals unless the radicals are the same, and these are both cube root of 2's, which means I can add or subtract the numbers in front. 2 minus 16 gives us negative 14 cube root of 2. And that's our answer. Let's take a look at number 10. I'm going to clear this off. We got square root of 5 times square root of 3 plus square root of 7. First off, notice I can't simplify any of these radicals, so I wouldn't even go down that path. This is a distributive property because we've got a single item here. So we're going to take that single item, in this case a square root, and we're going to multiply it times each item inside here. In this case, these are square roots also. So we're going to have square root of 5 times square root of 3, and we'll have square root of 5 times square root of 7. Again, when you're multiplying radicals together, assuming they have the same index, you multiply what's underneath. So we're going to have square root of 5 times 3 plus square root of 5 times 7. Now I can't simplify any of these because you have to have a pair of numbers, and these are all prime, so I can't break them down anymore. So this would be square root of 15 plus square root of 35. And that's our answer. square root of x minus 1 plus 8 squared. Now in this one you might think I'll just square this and square this, but you can't because of the plus in here. So we have to rewrite this as the square root of x minus 1 plus 8 times the square root of x minus 1 plus 8. That's what that squared means, is you multiply it times itself. Now this is just foiling. So we're going to take square root of x minus 1 times square root of x minus 1. That's our first items. The square root and the square root. And then we're going to take our square root of x minus 1 times 8. These are our outer items, this one and this one. And then we got our inner items, 8 times square root of x minus 1. These are our inner items. And we got our last items, which is 8 times 8. FOIL does not say you have to be dealing with terms. You can be dealing with anything. Now, when you're multiplying two square roots together, they kind of cancel each other out. It gives you x minus 1. Technically, you should worry about whether these are positive or not. I'm guessing that they will not put absolute value. They don't. Most times they don't. But normally if you have a variable coming out of a radical with an even index, you need to put absolute values around these. Plus square root of x minus 1 times 8 is 8 square root of x minus 1. 8 times square root of x minus 1 is 8 square root of x minus 1. And 8 times 8 is 64. So we're going to have x negative 1 plus 64 is 63. And notice that these radicals are the same. If radicals are the same, you're adding or subtracting, you add or subtract the numbers in front. 8 plus 8 is 16 square root of x minus 1. They probably have it in a little bit different order, I think I noticed, but that doesn't matter. Addition and subtraction are commutative. Let's take a look at number 12. We got square root of 1/10. Now I said earlier we cannot have a fraction inside of a radical. But we got a property that says you can split it up. You can put a radical around the top, radical around the bottom. So square root of 1/10 becomes square root of 1 over square root of 10. Now square root of 1 gives you 1, so I can go ahead and simplify that. Now this creates a separate issue because we can't have a square root in the denominator. But we have a property that says you can multiply top and bottom by this square root of 10. And this is what you'll always do if you have a square root in your denominator. You multiply top and bottom by that square root. 1 times square root of 10 is square root of 10. And square root of 10 times square root of 10 gives us 10. And that would be your answer. 13. We got 5 over 7 minus square root of 2. This one's a little bit different than the previous problem where we had a single square root in the denominator. If you have two items in your denominator and at least one of them is a square root, we can't have a square root in the denominator. That's still true. But now you're going to multiply the top and bottom by the conjugate of the bottom. Now conjugate means the first and last part's the same, but the sign in the middle is different. So the first part's the same. So I'll have 7. Last part's the same. So I'll have square root of 2. But the sign in the middle is different. This is a minus, so this will be a plus. And whatever you multiply by the bottom, you have to multiply by the top. So up on top, we're going to take 5 times 7 and 5 times square root of 2. 5 times 7 is 35. 5 times square root of 2 is 5 square root of 2. Nice part about conjugates is you can multiply your first parts and your last parts. You don't have to worry about doing the outer and inner for the FOIL. So 7 times 7 is 49 minus square root of 2 times square root of 2 is 2. So that gives us 35 plus 5 square root of 2 over 49 minus 2 is 47. And that's our answer. Number 14. We've got square root of 5x plus 7 equals 5. Now this is solving a radical equation. Our first step for solving a radical equation is to get a radical by itself on one side. And this is by itself. There's nothing in front of it, there's nothing after it, we just simply got square root. Now step 2 is to take both sides to a power equal to the index. This is a square root, which means we'll square both sides. Now when your index matches your power, they cancel each other. So that gives us 5x plus 7. And 5 squared is 25. Now we don't have any more radicals, so we're going to solve this like normal. And this is a linear equation at this point. So I'll take 7 over. So I got 5x equal 25 minus 7. 5x is equal to 18. And then divide both sides by the number in front of your x. So divide both sides by 5. And we get x is equal to 18/5. Now we should always check this, because with this process you get the correct answer, but sometimes you get false answers. Now if I put 18/5 up here for the x, the 5's would cancel. I have 18 plus 7, which is 25, and square 25 does give you 5. So it checks. Let me erase this. And let's look at 15. Square root of x plus 4 equals 8. Okay. First step is to get a radical by itself on one side. Well, this is by itself. There's nothing in front of it. There's nothing after it. We just got square root of something. Step 2 is to take both sides to a power equal to your index. Well, this is a square root, so the index by default is 2, so we'll square both sides. Again, the square root and the second power will cancel each other. So that gives us x plus 4. And 8 squared is 64. Take the 4 over. We get 64 minus 4, which gives us x equals 60. And again, we have to check this. 60 plus 4 is 64. Square root of 64 does give you 8. Number 16. We got square root of x minus 3 equals square root of x minus 39. When solving radical equations, your first step is to get a radical by itself. It does not matter which one you get by itself. This one's by itself. There's nothing in front of it, nothing after it. We simply get square root of x minus 39. So that's done. Step 2 is we raise both sides to a power equal to our index. Again, we'll square both sides. So we got square root of x minus 3 squared equals square root of x minus 39 squared. Now here we have a minus in here, and we're squaring it, so we have to rewrite this as square root of x minus 3 times square root of x minus 3. You can't just square the square root of x, and you can't just square the 3. The reason why is we got a minus in there. If you have a plus or minus in there, you have to rewrite it this way, and then FOIL it. Now over on the right side, the index matches the power, so they cancel each other. So I got x minus 39. Now I'm going to FOIL this, square root of x times square root of x, first items. The outer items, square root of x times negative 3. The inner items, negative 3 times square root of x. And the last items, negative 3 times negative 3. Now square root of x times square root of x is x. Square root of x times negative 3 is negative 3 square root of x. Minus 3 square root of x. Negative 3 times negative 3 is 9. Equals x minus 39. Combine these radicals together because they're the same. So we add or subtract the numbers in front. In this case, negative 3 gives us negative 6 square root of x. Okay. Now we want to get the radical by itself because we've got another radical. So I'm going to take the, just so I don't deal with all the negatives, I'm going to take a negative 6 square root of 6 to the right side and take the x and the negative 39 to the left side. Now over here we got x plus 9, that's what's already there. I take the x over the left side, becomes a negative x. I take negative 39 to the left side, becomes a positive 39. And I take the negative 6 square root of x to the right side and becomes a positive 6 square root of x. Okay, x minus x drops away. 9 plus 39 is, what is that, 48? Equals 6 square root of x. The radical is still not by itself, so we're going to divide both sides by 6. And we get 8 is equal to square root of x. Okay, now we're going to square both sides since we got the radical by itself. So we got 8 squared is equal to square root of x squared. 8 squared 64, and square root and second power cancel each other, so that gives us x. And this is maybe our answer. We have to check it. If I put 64 up here, square root of 64 is 8. So we got 8 minus 3 on this side. If I put 64 here, 64 minus 39 is 25. And square root of 25 is 5. And 8 minus 3 gives you 5, so that checks. And that's our answer. Let's look at number 17. Square root of negative 25. Well, I could rewrite that as negative 1 times 5 times 5. Now the square root, we're looking for a pair of somethings again. So here's a pair of 5, so that's going to come out in front as a single 5. And then negative 1 comes as an I. So that's 5i is our answer. Number 18. 3 minus 4i plus 9 plus 9i. Now in this problem, since there's addition here, these parentheses aren't doing anything. So that becomes 3 minus 4i plus 9 plus 9i. We can just drop them. 3 plus 9 is 12. Negative 4i plus 9i is 5i. And that's my answer. Number 19. I got 42 minus 7i. 6 plus I. This is going to be foiling. Multiplying our first items together. So 42 times 6. Multiplying our outer items together. 42 times I. Our inner items, negative 7i times 6. And our last items, negative 7i times I. Let's see. 12, 2, carry the 1, 24, 252. Plus 42i minus, that seems to come out too nice, 42i minus 7i squared. Now notice that the i's cancel, 42i minus 42i, and we always replace our I squareds with negative 1. So that's going to give us 252 plus 7, which gives us 259. And I'm going to double check that since that's high, some high numbers. Yep. 259 plus 0i. That's interesting that put 0i there. Technically, standard form says you should have a 0 there, but most books don't put that. Okay, 20. 1 plus 4i squared. Since, again, we have a plus in here, we have to rewrite this as 1 plus 4i times 1 plus 4i. And then we're going to FOIL it. We got 1 times 1. That's our first terms. Then we got our outer terms, 1 times 4i. Our inner terms, 4i times 1. And then our last terms, 4i times 4i. Gives us 1 plus 4i plus 4i. 4 times 4 is 16, and I times I is I squared. Now we always combine together i's. 4i plus 4i is 8i. And remember, we always replace our I squared with negative 1. So we're going to have 1 plus 8i. 16 times negative 1 is negative 16. 1 minus 16 is negative 15 plus 8i. And that would be our answer. And into the review.